Hi, my name is Nur Ayaniza binti Muhammad Rusdi. My features is search for a specific code. I will present option 3. Search for a specific code. This implements a linear search algorithm. How it works: the user enters a target code and our program scans through all 10 codes sequentially to find a match. Branching and looping. We use a counter control loop with register T1 as our counter from 0 to 9 and T2 holding the limit of 10. The instruction BEQ T1 T2 not found terminates the loop when all codes are checked. Inside the loop, BEQ T3 T9 code found compares the current code with our target, branching immediately when found. Register in action. T9 stores the search target. T0 holds the current array address. T3 holds each loaded code, and the PC advance sequentially except when branching. Data segment, the codes array at 40 bytes is accessed sequentially using LW T30, then incrementing the pointer by 4 bytes. Let me demonstrate. With codes 100, 250, 350, 5000, 678, 500, 600, 750, 850, 950, and 1000, searching for 5678 shows code found at position 4. Searching for 9999 displays code not found in the system. Both cases work perfectly.
Hi, my name is Naila Farhana and I'll be explaining feature 2, reverse the list of code. So, next is option 4, reverse the list of codes, demonstrating the two-pointer technique. How it works: we swap elements from opposite ends of the array, moving inwards until pointers meet. Branching and looping. This uses two loops. The reverse loop employs BGE as T0 as T1 reverse underscore done, comparing front pointer as T0 with back pointer as T1. When they meet or cross, we're done. The second loop prints the reverse array using standard BEQ counter checking. Key register. As T0 starts, add codes base address byte 0. As T1, add codes plus 36, the 10th element at byte 36, while ST2 and ST3 temporarily hold values during swapping. Text segment flow. PC executes load swap store sequences. LW T20 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 T0 loads from LW T30 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 T1 loads back, then SW T30 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 T0 and SW T20 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 T1 complete the swap pointers, move with add I as T0 ST0 4 and add I ST1 ST1 -4. Data segment modification. This is in place swapping. Offset 0 swaps with offset 36, offset 4 with offset 32, and so on, permanently modifying the 40-byte array. For demonstrating, starting with 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1000. Selecting option 4 outputs reverse list. So it will be 1000, 900, 800, 700, 600, 500, 400, 300, 200, and 100. Selecting it again reverses back to original, perfect in place swapping.
Hi, my name is Nur Atila binti Muhammad Najib and my features is only display odd numbers. Our program start collect 10 word access code from user and we validating each code between 1 until 9999. These codes are stored in 40 byte array in data segment. User then interact with our menu system that we offer 7 options. 4 of them we will demonstrate today. Each feature showcases different assembly programming techniques. The first one, branching and looping. The check or loop runs from 0 to 9 using BEQ T1, T2. Odd display done. The key is the filtering branch. And after NI T4, T3, 1, test the last bit. BEQ T4, 0, skip even. Branches only for even numbers. Only odd numbers fall through to print statement. This is nested decision making within iteration. Register usage T0 in the array pointer. Register usage T0 is the array pointer. T1 count. Interaction T3 hold each code and T4 start the bitwise end result. 0 or 1. The PC follows different execution path based on this result. Data segment access. Read-only sequential accessing using LWT3, 0 parenthesis T3 and 0 parenthesis T3 and 0 parenthesis T0. Incrementing by 4 bytes each iteration, no modification occurs. We are filtering display only. Text segment. PC executes, load and test conditional branch, optional print, increment and jump back. The path through print statement is taken only when T4 equals 1. Okay, for demonstration, with code, for example, 101, 202, 303, 404, 505, 606, 706, 707, 808, 909, 1010, option display 5, which is only odd codes in list, which is it will display 101, 303, 505 and so on. So the bitwise operation efficiently filter all the numbers value.
Hi, my name is Nordini Huda binti Abdullah and my features is find second largest code. Okay, finally, we come to option C, which is find second largest code. This is the most algorithm heavy feature in our system, but the idea is actually simple. How it works? We scan the array once and keep track of 2 values, the largest code, the second largest code. For each code, we check if the code is bigger than the largest largest become the second largest, and the new value become the largest. Second, if the code is between the largest and second largest, it becomes a new second largest. Otherwise, we skip it. Branching logic. This process uses nested branching inside the loop. First, BLE. T6, T1, check second. Checks whether the current code is larger than the largest. If not, we move to check second, where BEQ, T6, T1, next code, skip duplicate values. BLE, T6, T2, next code, skip values that are too small to be second largest. After the loop, BEQ, T2, T7, no second checks if the second largest is still -1, meaning no valid second largest exists. Next, data segment access. The array is read-only and values are succeed using index-based addressing, no pointer increments. This allows flexible access to any position in the array. Okay, lastly, demo result. Okay, this one, 500, 200, 800, 300, 800, 400, 100, 600, 700 and 900. Second largest code is 800. Case 2, all value is 555. No second largest code. And test 3, alternating 100 and 200. Second largest code is 100. This proves the algorithm works correctly and handles each case properly.